Yeah, the second year we're all like, oh yeah, we're the ones who had it one day.
Well, I wanted to do it with them, but
Yeah.
they were our big merged group from when the Hilliard program shut down. So we had people driving like hours in, and so I didn't want to make them drive 2 days.
Yeah, they were like, you should be thanking us because we got it and then for you.
Yeah.
I was like, yeah.
Yeah. And they had a different book too. I switched to this book, so
I was
I
like,
didn't
yeah,
know that.
we appreciate it.
Okay, so I do get very annoyed when people are talking. Whenever I start lecture, like that's fine right now. But I'm just warning you. Holy cow, nothing drives me more crazy than people talking. Whenever I'm up here talking, because then I stare at you and make it awkward. And that's I don't like. I have 3 kids at home that never shut up. So please don't be my other 30 children. Yeah. And I might got the wrong book twice. Oh god. Yeah, here. For those of you that haven't gotten it yet, that's this one. You don't need the workbook because I don't use it a whole lot, but when I do, I'll just hand it out to you. Hand the pages out to you. So if you already got it, cool. Do you? Okay. So this is truly just basic math. There is no like radiology about this at all. This is strictly just basic math. And then we it's 2 monitors. Okay. So these are the chapter objectives. That's not a blurry photo that I took. That's actually what my textbook looks like. Isn't that cool? Blurry. Whatever. It was free. So I do know how to do. So those are the objectives from the chapter. Basic multiplication things. This was just a table that I thought was particularly helpful for those of you who has had math within the last like 2 years. How about 10 years? Okay. So not bad. But I mean honestly, if you passed college algebra, this class should probably not be so bad. But this is one thing I did want to point out. We can see this for now, but it is going to change to the dots. So if any of you forgot that multiplication can be demarcated as a dot too, just make sure you're aware of that. Or when we're talking variables, they'll just be next to each other, and you just need to know that that's multiplication. I try my best on my slides to like make the equation look like a nice equation, but sometimes that formatting just really just to send you. So I try and then I go on. We gotta be able to do things with fractions and decimals, so we'll talk about that. Determine significant digits in a number. That's like where we get into rounding. The answer to the question is 38.625, 7, 9, 10, 12, 13, 14. All of those, we need to just kind of be able to determine how you're gonna give me that answer, okay? How you're gonna round it. Perform calculations in scientific notation. That's a big one because we deal with very, very, very small numbers and very, very, very big numbers. So understanding scientific notation is important. X-ray photons are very small, and we talk about crap loads of electrons and crap loads of X-ray photons, and so we are going to become friendly with scientific notation. Basic algebra expressions, that's great, and then we got to know the SI system and be able to convert basic things like minutes to hours and seconds. Wait, what was I going to say? Like meters per second to other different things. So we will get to all of that. Oh, I'm out of lecture shape. It's been a few months. I think I wouldn't be screaming kids all the time. Just kidding. Okay. Fractions. So this mashup math website, I just love. It's like elementary school, but I just love the graphics. It's fabulous. And I do have the links if you want to go to the website, like you need some extra help. The link to where I got the photos on the slides, you can click on it, but I do like it. It's visually pleasing to me. So adding and subtracting fractions. If it already has a common denominator, easy peasy, right? We know what the denominator is. D for down, it's on the bottom. The numerator is on the top. If we're going to add or subtract, we have to get it to where they're the same if they're not already. So We just have to do the same thing to each side. So if we start out with a 2 and a 7, we can multiply that by 7, multiply that by 2, we can get our 14, and then add and subtract accordingly. Okay? There are times I'll do examples on the board. If it's pretty cut and dry like this one, I'm not really going to go through it on the board. Okay? But if I'm going to skip it and you don't want me to, just let me know. Okay? I'm happy to do whatever, except dance. So we're good on that? Okay. So when we're multiplying fractions, we don't have to do the common denominator business. We just go boom, straight across. It's very nice. If it's easily reducible, I'm always going to want you to reduce it. You know what that means, right? Okay. Divided by 2 or whatever's going to be handy. Okay? So that's pretty cut and dry. I like it. Division. Similar, but don't forget to flip it. And this is another one of those little mashup math things, but I was like, keep, change, flip. I just thought that was fabulous. You keep the first one, change the sign from division to multiplication, and when you flip that, then you can just multiply straight across like you did before. So I kind of like, if you have a hard time remembering that, a lot of us in our brains just cross multiply and do it that way. But if you forget which one to put on the top or something like that, this is a good way to keep it straight. Keep, change, flip. Make sure you flip that, and then you just go straight across. Okay? Cool on that? Okay. Yeah.
I was just wondering, because I know we did some inverse law equations. But those were like equal to each other, and that was cross multiplied, right?
Yeah. And we'll do so many of those. You'll just.
I thought so. I just wanted to make sure my brain was remembering that right.
So as we go through, there is some math sections in RATE boot camp, but that's the stuff that's specific to radiology. So there's a lot of inverse square law. Nicole, have you do any of those over the summer?
Some of them, yeah.
Yeah.
Oh, so you already did them all?
Actually, I accidentally did
I
one.
did. Okay, good. They've added. So last year I had all my ducks in a row. It was great. I had these beautiful schedules made out. Every RATE boot camp assignment you would have to do the whole semester, and then boot camp went and updated everything like 2 weeks into the semester. Some of us did all of them. Well, that's cool. You got good practice. It'll be fine. Decimals. So this little table is in your book, but there's also like 9,000 other ones. Online, to go much farther down the line, and that's all fine and good. But I mean, just take note of this, where it is in your book. What page is that? 4. So, because when you're working on the worksheet or doing some practice questions, you'll want to double check yourself, because I always messed this up. I don't know what the deal was. I would think I knew it, but I always just needed to look at that table to answer all those questions. So for decimals, that's just the list of all the stuff we're about to talk about. What we're going to do. Review decimal number place. That's the lovely table. Addition, subtraction, multiplication, division. Converting fraction to decimal. Percents to decimals, and the decimals to percents, which hopefully we all do. I know shopping, when I became an adult, like when shopping and sales, that really helped me, like with mental math, you know, trying to figure out how much that is actually going to be off, or should I wait until it's 60% off, or 40, whatever. So, addition and subtraction. That one's pretty cut and dry. Line up your decimal points. Add in the zeros to fill in the positions, add and subtract them as whole numbers, and then drop your decimal point down. That's like the old school way, you know, when you're writing it all out yourselves. And I mean, granted, we all have calculators, and you will need one for every test in here. There are some up here, but because one year I was like, I'm gonna buy everyone a calculator, so no one has to say, oh, but I went to the dollar store. So none of them work. Not none of them, some of them don't. Sometimes when you put an 8, it looks like a 0. Sometimes when it's a 0, it looks like an 8. So that's kind of not okay. So if you want to try one of those, if you forgot yours, you're welcome to these up here. Just know, use at your own risk. Multiplication. This is what's over there. Multiply them as if they are whole numbers. Then you can find the sum of the decimal places. So after you have multiplied it out, you can start by ignoring the decimal places, right? Multiply it out and then count. Okay, 1, 2, 3. And then you move over, 1, 2, 3, put your decimal point in, and ta-da. But I know we're going to be using calculators, and that's fine. But
Are we gonna use calculator on our
yeah,
But it's built into the computer, right?
Correct.
You can't bring one.
correct.
Okay.
Any questions about that? Yeah.
Are you ever gonna like not let us use a calculator for certain problems?
No. No. Okay. We'll look at that. Except for this, you'll have to do this by hand. Oh, God. You guys knew I was kidding, but your faces were still funny. But if you do want to do it on paper, you forget a calculator and all these suck real bad, you might need this. So, move the decimal point, because I don't let you use your phone. I should say that. Quizzes, tests, all that business in here, no phones. Yeah.
So if you give us worksheets, we want to see like the math worked out on the worksheets.
Not like this. No. Because most of the time, I'm not going to be asking you simple questions like this. It's going to be solving the problem. So there are several steps. So I want you to kind of at least write out the steps. But the calculation part, I don't ever really need to see. I don't need you to write out what you put in the calculator. But if you... So we get into like Ohm's law with amps and volts and things like that. And so Ohm's law, we can solve for 3 different things. And so sometimes you have to reorganize that equation. And so I want to see you write out how you organized it and how you set it up to make sure you're solving for the right thing, okay? And the more work you show me, if you want to come up and duke it out over your answers and say, well, this is actually a 5. And I'm like, well, it looks like an 8. And then if you show me your work, then maybe we can talk about it, okay? So, but if it's just cut and dry the answer, then we don't have a lot to chat about. You know what I'm saying? Okay. So anyway, like this says, or you use a calculator. Because most of us are definitely going to do that. So, I'm not going to talk about that all the time. We got other stuff. Converting a fraction to a decimal. Use your calculator. Converting a percent to a decimal, though. This is something you need to know. If you start out with a percent, move the decimal 2 positions to the left. Boom. Okay? 65.3% turns into 0.653. Converting a decimal to a percent, you're going to move it the other way. So, if you start with 0.3091, when you move the decimal, you have 30.91%. Okay? Any questions? Okay.
So glad we use a calculator to convert fractions.
Oh, yeah.
That's the one thing about math that I was never a fan of.
My dad is like a metal worker. He can build, weld, anything, and he has all of the fractions memorized as decimals. He's like a wizard. I was in the shop with him building something, and I was like,
I have most of the quarters and beats memorized because it's, I mean, if you do anything
Oh, yeah.
construction-wise.
right. He's got like the 30 seconds. Like I was using calipers. I made these dice for my husband for our anniversary out of like solid aluminum. And so my dad had like the square and calipers, and he was like, "Oh, you need a 0.275." Okay, cool, Dad. Thanks, buddy. Moving on. So, okay. Computation with values. So, significant digits. That might be a term. It is kind of weird to get this one, and I'm not trying to make it more difficult, but we do need to know for the sake of how to answer future questions. All right. Like how many digits do I need to include in this answer when there's 30 at the end of the decimal, right?
So, and is this the same thing as like significant figures in chemistry? Like the chemistry class I had to
Sort of,
take?
yes.
Yeah, it is.
This is
Probably, yeah.
significant digits. Sig figs was what they call it. Significant.
Not a chemistry teacher.
Okay.
It's almost
That'd be
Well,
awesome.
for instance, one of the chemistry teachers for C, for example, it would be 3 significant digits, not 4.
Correct.
Yes.
Yeah. So that is what this
It's
is.
basically the same thing.
Yeah. I mean, it's say the same thing. I think it'd be the same. So, what you're gonna do is count all non-zero digits, count all zeros between non-zero digits, and count all zeros at the end of the decimal value. So, and I cannot remember if this is on it. Yeah. I'm trying to get there. Anyway, so where are they? Oh. I love and also hate books. Here we go. So in the book, the first example that they give is 7.14 MR. MR is millirankin. We'll get to that later in this class when we start talking about our specific units of measurement. So 7.14, how many significant digits would that be? 3, right? Did you have your book? Easy answer. So the next one is 90.104. 5, right? Because there's 2 in the front, 3 in the back, and there's a 0 in between the non-zero digits, so we still have to count that per the second bullet, right? The next one is 0.048.
3.
2. I know, it seems so backwards.
Okay, so
Right after
so
the
B
decimal
up there.
doesn't count.
We're gonna do those next.
Okay.
We're doing the ones in the book first. So, to me, it's backwards. To me, I want those to be
Yeah,
significant,
the
and
one
then the
right
next
next to the
one.
decimal seems to make more sense
Right.
than the one before or after.
But if you have the next example in the book is 7,300.
2.
No, in my head I want it to be 4, but it's actually 2. Those zeros in the back don't count, but the ones on the left of it do. I know, it's so cheesy. And then 6.900. Annoying, right? Whatever you want it to be, just think backwards. At least that's what I do. Yeah,
But it doesn't make any sense.
I know. Me either. I got nothing for you. It totally doesn't make sense to me either. You just have to.
Let's say like
go with it.
it was like you said 7,300, but if there was a decimal point at the end, it would be 5, right?
Yeah, if there was a decimal and then like a 2, then yeah,
Okay.
it's really dumb. Okay, so let's do. So, on my examples over here, how many significant digits are there for A? 4. Correct. How about B? 3. Correct.
Which
Which-
zero is it?
I was just
Zero
gonna
at
ask
the,
you.
the 0 at the end on the right is your significant number, the one on the left is your non.
Okay, that's what I thought.
And then-
Chemistry was my last prereq I took before I got this. So we had to do all those things.
And then C.
3.
Correct.
Can you explain it though, because I'm still,
I can get you
So-
some YouTube videos that I watched on it to help. That helped me
I
a lot
didn't
with
take
it.
chemistry, so.
So basically,
So-
anything right next to the decimal.
Count all zeros at the end of a decimal value. That's a decimal value. So they still count. Hey! There, I did it. So that's a decimal value, so it's still, okay? Count all zeros at the end of a decimal value. Okay, great. Is this one a decimal value? No. So it's not important, which bothers me, because I feel it should be,
Yeah.
but it's not.
Yeah.
My feelings don't matter. So that was just 3.
They count the 0 as a placeholder, so it's not
Right.
important.
Perfect. Okay? So there will be more practice of that on the worksheets. Yeah.
So if there was a 1 in front of the decimal, then you have 5.
Yes.
On B? Yes. Jill?
Okay.
If you have 10 in front of it,
Dramatic button. Okay, so precision. This is talking about the decimal position of the last significant digit. So this is where you're going to want to go to your little table, friend, at the top of the screen. So examples in the book, .0218. So I'm writing it. .0218.
So that would be hundreds.
Yeah, because there's 1, 2, 3, 4 this side of the decimal. So that's how precise or
Oh,
accurate.
the left.
That's another word you could say.
Oh, see, I was thinking the first one.
Yeah, precision's like the math group, but accuracy is something else that I think of. So, now let's do A in there.
A hundred.
So it's 2. So the white column is the decimal, and then there's 2. So then you go over to the 2, over 2 spots, and it's hundreds. And then what's B? Yeah, it's the same as the one from the book, because there's 4 spots you gotta go over, so it's 10,000. So the more you do this, the more you'll have it memorized. And then what's C?
Hundreds.
Correct. Okay? Are we hunky dory on that? No? Okay. Okay, rounding. So, this is where you'll kind of think about your significant digits a little bit. When we're rounding, we all know how to round numbers. If the one to the right of it is less than 5, it stays. If the one to the right of it is higher than 5, then we up it, right? So we all know how to round. But for your answers on problems, you're going to want to look at the significant digits of the numbers in the problem. And that's typically, so if you're adding 25.14 and 3.1, you're going to, that was kind of an easy one. All right, you're going to 5. A little bit nice if I would have lined up the decimal points, but didn't.
So,
28, 6, 5.
Okay. So then would you leave that answer, or would you?
I rounded up to 27.
Yeah, so you can, for me, you can stick with like the smaller of the 2, right? So this number has 3 to the right, this one has 2, I'm good with 2. As long as you round it correctly, if you jack up your rounding, then it'll be like, oh, that's not the right answer. Okay. Please round to the hundredths place when necessary. I don't really need any more than that. Unless we're talking about really specific things. Typically for me, you can round to the hundredths place, and that's going to be fine. So how would you round A?
12.7.
How about B? 0.8. Okay. And then C?
10.8.
Correct. See, y'all were scared about this class. I didn't go back yet. Yes.
Sorry.
Oh, sorry. Can you go back?
0.8.
Point remain. Right?
Brain's trying to catch up.
Okay. So, adding and subtracting approximate values. So, I mean, I know these don't really look approximate because there's decimals and such, but there are going to be problems where it says it's approximately, and then it gives you some number like that. So, the answer should be no more precise than the least precise value. So that's kind of what I was saying with this one. The least, oh look, least, loser, typo on the slide. With the least precise value. So which of these is the least precise?
25.4.
Correct. So that's why you can just go with that. You don't have to have the 3 because this one is 2. So that was the least precise. So you can just keep it the 2. Okay. So for the top, which value is the least precise? And if we add them together, which one's correct? Correct. Indeed. The least precise one is the same thing, we just have rounded it off. So this one was the least precise, so we don't have to have any more numbers than the least precise one had in the whole problem. So that's why we can knock off the 2's and just call it 0.6. Yeah.
So, like, say for instance, when there's questions, will like, because you said with rounding with you want hundreds, but if we're doing like precise value, will it be like, what's the word I'm looking for? Will it be expressed in the problem, like if you want it rounded, like you want it rounded, or precise value? Because you said round everything to hundreds, but the least precise is at the tenths on these two.
Well, I'm not gonna trick you that way with the answers. So the book, like on the worksheet, the workbook is probably, there's gonna be set questions that are about precision. But when we get into like problems and stuff, I mean, if the answer just has 1 decimal point, then you don't have to put a 0 there. But if there's any rounding, you can just stick with the hundreds. Because I typically write my own math questions because we do so much practice doing all the math in all the chapters that I've already used up all the ones the book has. And so by the time I get to the test, then I'm making my own.
My chemistry teacher tried to be very tricky about that stuff, so.
No, and I'm not gonna put, like, if this was the question, I wouldn't put D as like 2,523.60. Like, I wouldn't do that and give you those 2 options to pick from. That would be a jerk. So you'll know what the answer is. I might put different units on there. I am kind of tricky with that. If we're talking about grays and milligray, if the answer is in milligray, if it's 100 milligray, I'm going to put 100 gray on there too, because you've got to pay attention to your units always. So I will trick you like that, but I wouldn't be tricky about that. Yeah.
Why is C the least precise among the other two? I guess I'm a little lost.
Because there's just one digit. It's precise.
The higher the value of the decimal point, the least precise.
The more precise.
And so you can go back, we're talking about this, that table. So it's more precise the farther to the right you get on the number line. Or that number line, that table, yeah. Okay. Oh, we have 20 minutes, y'all. So 10 slides. I don't know, we'll see. We always have tomorrow. That's what's great about this. So, powers of 10. So we've all done this before, right? It's just been a minute. Ow. Everyone's got potties?
I got it. Sorry,
Okay, no, go for it.
I have to go to the bathroom.
No, go. If you need to go, go.
I can wait.
I can't.
Okay, so the decimal system and the metric system. So yes, while we are in the America, we're going to be using primarily not our regular system of measurements. We are going to be using the metric system because it's a science thing, right? We're science people. So this is like the normal, right? So A is the base, N is the exponent. And I apologize if these are small now that I have them up here. They are kind of small. So those of you in the back, sorry about that. I'll make it bigger for the next one. So we can have positive and negative exponents, right? We can have 9 to the negative 3, we can have 9 to the positive 3 power. So when we have 3 cubed, it's like we're taking 3 times itself 3 times, right? Okay, good. If we have negative integer exponents, they kind of just pretty much cancel each other out. Well, not all the way. So it would look like that. 0 exponents, and we're gonna do examples of all of these soon. 0 exponents equal 1. It doesn't matter what A is. Ooh, that shouldn't be capital. So, it doesn't matter what the number is, it's going to be 1 if it's a 0 power. Okay? So, all the scientific notation fun. So, ordinary numbers are the big, long, crazy decimal numbers, right? But that's what we're going to get into such large numbers. We have things where it's like 10 so-and-so times 10 to the negative 15 because it's just so small, okay? We're talking about the sizes of electrons, the sizes of photons, with some pretty small numbers. So when we're converting ordinary to scientific notation, we're going to move the decimal point to the position following, and this is wordy and I apologize. Move the decimal point to the position following the first non-zero digit. So if you ignore the decimals and everything, the first non-zero digit of this is what? Going from left to right, what's the first non-zero? Yeah, 6. It's not a 0. Neato. So we're going to move the decimal there, and we moved it that way, so it's going to be a positive 1. That's a corny number to put in scientific notation, but you could put anything in scientific notation if you really wanted. Okay? So for this one, what's the first non-zero digit?
1.
Right. And so we have gone this way now. So now we're going negative. So it's 1.529 times 10 to the 3 because we had to move the 3 spots. 1, 2, 3. Rightio? Okay. Converting from scientific notation to ordinary notation. You're just going to have to remember the other way around. Okay? If it's positive, we're going to move the decimal to the right. If it's negative, we're going to move it to the left. There's lots of practice for this on the worksheets. If the power is 0, the decimal remains in the same position. Okay? Any questions? So, dimensional analysis is just a really fancy way of converting, say, you're going to convert something from one set of units to another. So that's like going from feet to inches, minutes to seconds, ranking an hour to minutes. So that's the kind of stuff we're going to have to be converting, okay? Not so much feet to inches, but sometimes minutes to seconds, sometimes hours to minutes, sometimes minutes to hours, okay? So, page 7 now.
That's like all the nursing classes that just got out, and look like lines for bathrooms.
We do have our bathroom back here too, but I
There
can't
was
always
a line there
guarantee.
too.
Well, ours back here.
Oh, yeah, that's right.
Sometimes it's not unlocked and we don't have a key for it, so if it's not unlocked, then we go crazy about it. Okay. So, the example in the book. So I don't have my book. Normally I would just carry it up here. So we'll do the example in the book, and then you'll have lots more practice on the worksheet. So this is going to have us go, we're going to convert 7 feet, 7 feet to inches. So it's nice to kind of set it up like this. 7, and then we've got 12 inches, because that's how many
Are in a foot.
Thank you. 12 inches, keep your label on there. And that's 1 foot. Those two are friends, right? And then you can say equals. Because we're going to multiply these. So if we multiply that, what do we end up with? 84. Correct. So if you really have to like wrap your head around it, you can rewrite it. You can do 7 over 1 times 12 over 1. And then just go straight across. Okay?
The mole conversions and all that.
Whoa. Man, I cannot write today. And so then we have 84. 84, what's our unit? Okay. Don't forget to put that in your answer either, because even if you have the right number, I'm totes going to mark it wrong because the units are wrong. Okay? So it'll get a little weirder. We'll go from meters to kilometers on some of the examples, but you just kind of lay it out just like that. Because we're short on time, I'm not going to do any more examples like that. You'll have some on the worksheet. Okay. Signed numbers. This is just negative, positive, right? So this is whenever we talk about absolute value, this is just something that you need to always be able to answer these kinds of questions. The distance from 0 to that number on the number line. So we ignore the sign, right? If it's a negative number, if we're talking about absolute values, all we need to know is the distance to 0, right? So if the number is negative 2,402, what's the absolute value?
2,402.
9, yeah. Okay. Corny examples. What's the absolute value?
6. 9.
Perfect. Okay. That's what these two lines mean. That's how you're always going to know that it's looking for the absolute value. If you see a number between those two vertical lines, that's how we're going to be able to say that it's the absolute value. Okie dokie. Okay. Order of operations. Who remembers? Well, I mean, it's on the board.
Please
But,
excuse my dear.
yeah. So, but this is important. This is very important because you are going to have problems like this. So as much as you can think about Aunt Sally, the better. But that was a good little graphic. Again, I love like elementary school math graphics. They're fabulous. They help me remember all those things. So yes, PEMDAS is what a lot of people say. Please excuse my dear Aunt Sally. Parentheses, and then exponents, and then you multiply, and then you divide, and then you add and subtract. So that is the order in which you go from left to right, whatever comes first, okay? So there it is again. Keep an eye out for instances to use the distributive law. So that's one that kind of throws people sometimes, is this distributive law with parentheses. So when we have a number and we're multiplying two other numbers that are being added in parentheses, we can distribute that too. So we can have 2 times 4 plus 2 times 3. So then we end up with 14 because we have 8 plus 5, right? Yeah.
I thought if you had like variables inside the parentheses, you would add those together and then multiply. Like say for instance, if it was 4a plus 3, then you would distribute. But since they're just 4 and 3, like the variables.
Variable, it's going to be the same answer regardless.
Yeah.
But if there's a variable,
7 times. Oh yeah, I guess you're right. It is 14. Never mind. As it is the same.
if there's a variable, you can distribute.
So it's this one.
30.
Correct. Thanks. I know. Y'all were scared. This isn't that bad.
Yet. Keep forgetting the yet part.
Rules for exponents. So, this one is also very important. Probably more so than the last one. Because we're going to be multiplying and dividing a lot of things in scientific notation. A lot. So, luckily, there's that lovely little graph telling you how to go about it. So when we're multiplying two numbers with exponents, when you multiply them, what do you do to the exponents? Add them together. If we're dividing, you subtract the exponents, okay? If we have a power of a power,
Multiply them together.
then we multiply them together, yes. If we have the power of a product, then we distribute that power to both of those numbers. If we have the power of a fraction, we, again, distribute that down to the two of them. We already know that one. Anything to the 0 power is 1, so that's 1. If we have a negative exponent, then it just is kind of the inverse. We have it underneath the 1, right? As opposed to all the other times. Okay, so for the examples, what do we end up with on the first one? What's the first step anyway? You can do that first, yeah. So what's the addition of our exponents?
It's 10 to the 7th.
Okay. So then we're doing what else? Somebody's got a calculator, dang.
Oh, hold on.
still multiplying, right? This exponent is -8, and this one's 5.
You said it's -8,
Yeah, this one is.
so it would be,
Times the -3
Correct?
times 16.672.
Yes.
What is it?
These multiplied together is 60.72. And then we're still adding the exponents because we're multiplying. So -8 plus 5.
it's -3.
Yes. All right. So now we are dividing. So what happens now?
10.
So this one is 10 to the 14th, and this one's 10 to the 10th.
It's 18.27 times 10 to the 10th. Oh, it's division. No, wait, I lied.
4.14 times
10 to the 4.
Yes. Great.
What? 1 over 5 over -3. 1 over 5 to the -3.
No, it's gonna convert to.
It's 1 over 5 to the 3rd.
Yeah, you drop the negative whenever you put it under the 0. Okay. Cool.
Is that the override? I think so.
Oh, I have no idea. Okay. Examples for later practice. We're not going to do all of these. This is just funsies for you later to practice all those same things. So we're going to zoom along because we got 5 minutes to spare. And we got. So, important formulas of algebra. Again, I found this on the interweb, just a handy little resource, but it kind of shows you how to go about anything you may see. Addition and subtraction principle, if we're solving for x, what are we going to do here? Add 6 to both sides, great. What are we going to do here?
Subtract 19.
Fabulous. Thanks. Okay. So, we got some units of measurement. We're going to talk about that just a little bit. The primary or fundamental, you'll hear either one of those words. Depends on what textbook you're looking at. I believe this book says primary. My old book said fundamental units. So there you go. Or quantities. These are the 3 that, like, everything else comes from, basically. So we have length. We measure that in meters. We have mass. We measure that in kilograms. And we have time. It's measured in seconds. It's fabulous. So then we have these secondary, or sometimes called derived units, or quantities. If we combine some of these primary quantities, one or more of them, with other units, we come up with these secondary quantities. So they're a combination of one or more base units. So an example of that would be velocity. That is your length divided by the time, right? I mean,
Distance.
we'll talk about that. But that's what it would be. That's not one of the primary or fundamental units. That's something that we have to combine other things with. Okay? So then we have special quantities. That's us. We're very special scientists. We have a lot of our own units. So in every area of science and technology has some that are specific to them. Ours we'll talk in depth about, but we have exposure dose, effective dose, radioactivity has its own units, and so we'll talk about all of those. But be able to tell me the difference between primary, secondary, and special quantities. This is another thing. We'll be using it a lot, but get familiar, get cozy with the prefixes, because the more cozy you are with these prefixes, when you're reading math problems, you're going to be able to say, okay, I'm dealing with really large numbers or very small numbers or something like that. You're not going to have to try to break down every little part of the problem, okay? The more you're comfortable with the megas and the millis and the micros, and we are going to get, those are kind of the most common ones that we're going to use. We do a lot of micro. We do a lot of nano, too. So, are you familiar with that one? Look over page 15 in your book, review the more complete table of prefixes. This was just a dabble. But it's going to let us express very small and very large numbers, just like with scientific notation, okay? Because we deal with KVP and mass, right? kVp is kilovolts, right? So instead of writing 70 kVp, we could go ahead and write 70,000 volts if we wanted to, but we don't. We would rather keep it short and sweet, right? 70 kVp. And so you'll get really tired of me talking about all that, but it's just the first day, so you're not tired yet. Okay. That's all I got. Read the chapter, go over your notes. I'm going to give you, as you're leaving, I'll give you the worksheet. Or I can go around now.
If anybody needs help.
It'll be zippy. You're welcome.
There's two. Yeah. Where do we get the markers? Online, I got to.
You wanna put in, like, lead,
Ah! Okay, so basic training day yesterday. He said, I loved it. And I said, what? And he was like, I love basic training. I was like, why? We make such a good relationship. You don't have the phone, you
Yep. So glad about it. It's not even noon yet.